Hello everybody, I'm Dr. Ujjwal Vishwas, a faculty, Department of Computer Science and Engineering, IIIT Bhagalpur, Bihar, India. I'm presenting my paper on XGBoost for novel predictive model to classify student performance based on academic metrics. The co-authors are Seda Sinha, a MTech student, and Dr. Om Prakash Singh, a assistant professor at the same institute, IIIT Bhagalpur, Bihar, and Mr. Hemanta Borua, a PhD student at IIT Guwahati. The presentation content are as follows. The first one is the introduction. In introduction, we will briefly discuss about these terms and terminology. Next, this literature review, research methodology, and results. And finally, we'll conclude and express our views as to related to this research. In introduction, accurate student performance prediction become very popular nowadays. The reason behind it is that this this helps lots for educational or any educational institutes to monitor student, and ultimately it helps to increase the performance of the students. And it also challenging for predicting or providing a robust predictive model using machine learning to get high accuracy. Next is literature review. We have observed these are very recent and directly related with this research work are four contributions given as a literature review here. This first one is ML-based intelligent real-time feedback system. It actually developed a real-time feedback system for blended learning environment. And the key finding from this, it is observed that prediction and ML helps a lot for monitoring as well as giving feedback to the student in a blended classroom environment. And the second one is analyzing and predicting these student performances by means of machine learning review. And in this review, we observe that there are classical ML models and also this different ML models which used for these student performance predictions. And the third one is related to this interactive visualization. This is directly related to the classroom monitoring, and it also ultimately improve the learning outcomes. And here also you observe this student states very key factors for this monitoring and visualizing these classrooms. And the fourth one also this real-time ICT based interactive learning analytics, and this implemented ICT for interactive large classroom learning for visualizing this monitoring. And here also this student states and these identifying these metrics have these key roles. So based on this, we observe that there are challenges to identifying these metrics and this prediction model for monitoring and visualizing this classroom environment. So our research methodology address these problems, and it follows these three basic steps. This first one is the design of the model, and it is a very generic like the previous works, and it's have some steps starting from this data preparation, model training, model evaluation, and hyperparameter tuning. This also identify this feature importance. And the second important part here is to deploy the model. And in deployment, we focus on how to loading these data set and pre-processing this data and collect this data set. And data ultimately, we also visualize the data that helps a lot to identify the importance of the metrics. Here we use this box plots for visualization. And next is data transformation and the model training and evaluation. And finally, this data visualization for analysis the performance of the model and the metrics importance. Now, this is a very generic notion of these XGBoost models, and this figure number one, which illustrates the notion of the XGBoost models. And it is in the left side, it's a sequence is given starting from this point, and this is predicting the academic performance. It involves some steps, and in every step we have given this input features to the model and build the ticket tree, and this is a hierarchical tree to maintaining or improving the accuracy or other measurement performance measurement for the model performance. And the second one weighting increases the importance, gives the importance for the metric. Those are important with respect to the prediction. So these trees and these weighting are very important, and all these models parallelly predict this and analysis, and finally we combine these results and actual predictions happens. Now, this in the next this research methodology, this figure to illustrates how our models work for this for the prediction for academic performances. It shows this data set X to Y, and this data set it basically in our case this academic metrics we will discuss later. The input, it takes this input and generates this tree structure, and also it generates n number of trees like this figure, and it also feeds this regression tree to the target output. Actually, target output here this predicting this student performances, and now it produces this F1, F2, and this Fn updated, and these trees are ensembled, and finally the prediction of this student performance are ensembled. Now, this is the part of these visualizations, and these visualizations help to identify the data sets and their importance in predicting these academic performance for this research purpose. Now, we have collected 1,020 student data for this research from the Department of IIIT Bhagalpur, Bihar, and it contains 7 columns in the data set, starting from this mid-semester exam, quiz 1, quiz 2, homework 1, homework 2, and end semester marks and this final grade. And we observe this, these are the mid-semester exams, and end semester exams have this higher importance, and the heat map illustrates the metrics used and their distribution in this figure. Now, the similar results like this, the distribution of the matrix and their relations are present here. Here, this scale are shown in 0 to 100, and for this all the research like mid semester quiz 1, quiz 2, homework 1, homework 2, end semester mark, and this final grade. And these diagonals are the histogram representation, and this distribution and data are shown in figure 4 for the matrix and their relationships. Now, this one figure 5 illustrates the box plot to data outliers. For identifying outliers is very important for any prediction. Similarly, we observe that in our data set, this Q1 have these outliers only, and other than that are very similar and good enough to predict this student performance. Now, this finally this results, and this table 2 shows the model performances, and these are the very basic and this classical model, and with a advanced model which is this XGBoost. Here, if we observe this metrics starting from this accuracy, precision, recall, and equivalence score, these are very frequently used metrics. These are very frequently used metrics for any predictions. So for our purpose also, we use the same prediction algorithms like the decision tree, SVM, random forest naive bayes, neural network, and KNN, and finally this XGBoost. And we observe the decision tree performs data, and also parallel this XGBoost instead of this SVM. But here we observe basically SVM are not working on this better on these limited data sets. And finally, this conclusion, we observe this XGBoost model offer improved accuracy in the performance prediction due to its internal architecture and these different technique, whatever we discuss in this figure 1 and figure 2. Based on this, we observe that this XGBoost are a very good predictor for academic performance metrics. In conclusion and in future work, it is very interesting to integrate of real-time data for continuous monitoring of these students, and it will help to monitor student in and as well as the visualization, which we discussed in this literature survey as well. The major applications which are also use these student performances for giving feedback and visualization of the classrooms. So these are the 4 references. So these are the 4 key references which already mentioned in the literature review. And now, thank you. And any questions from the audience?